In this video, we're going to do some applications of quadratic equations, but specifically the applications that we're going to look at in this video are going to relate to number problems. When we're solving number problems, we're often asked to find two consecutive even integers, two consecutive odd integers, or two consecutive integers. And if we're going to find those numbers, then we need to know how to represent them algebraically. So let's first talk about how to represent consecutive even integers algebraically. An example of a problem that we might be asked to solve might be something like this. Find two consecutive even integers whose product is 48. Well, in that problem, we're being asked to find two back-to-back even numbers that when we multiply them, the product is 48. Well, obviously, we can find that pretty easily. We know that 6 times 8 gives us 48, and 6 and 8 are consecutive even integers. And negative 8 times negative 6 gives us positive 48, and minus 8 and minus 6 are consecutive even integers. But how do we represent consecutive even integers algebraically? We're always going to start by letting x, or any variable of your choice, could be y, z, a, b, it doesn't matter. We're going to let x equal the smaller of the two consecutive even integers. So this one's going to be the smaller even integer. Well, if x is the smaller of two even integers, how could we represent the larger even integer using x? How far apart are even integers on the number line? Like 6, 8, 10, 12, 14, 16. To get from one even integer to the next even integer, we would have to add 2 every time. So if x is a smaller even integer, then x plus 2 would give us the larger even integer. And that's how we're going to algebraically represent consecutive even integers. X will always represent the smaller, and x plus 2 will always represent the larger even integer. What about consecutive odd integers? Well, just as we did with the consecutive even integers, we're going to let x represent the smaller odd integer. Now think about how far apart odd integers are from each other on the number line. Numbers like 3, 5, 7, 9, 11. Each odd integer is 2 units away from the next consecutive odd integer on the number line. Because odd integers are 2 units apart on the number line, we'll let x plus 2 represent our larger odd integer. So yes, we represent consecutive even integers and consecutive odd integers the very same way, because even integers are 2 units apart on the number line, and odd integers are 2 units apart on the number line. But how would we represent algebraically consecutive integers? Now here we're not talking about consecutive even integers or consecutive odd integers. We're just talking about consecutive integers. Consecutive integers are numbers like -1, 0, 1, 2, 3, 4. Well, just as we did previously, we're going to let x represent the smaller integer. But consecutive integers are only 1 unit apart on the number line. So I only have to jump 1 unit from the smaller integer to get to the next larger integer. So rather than letting x plus 2 represent the next integer, we'll let x plus 1 represent the next integer. So consecutive integers can be represented by the variables x and the variable expression x plus 1. Let's take a look at this example. The sum of the squares of 2 consecutive even integers is 52, and we have to find all such integers. The first thing that I notice here is that we need to find 2 consecutive even integers. And we mentioned on the previous slide exactly how to represent 2 consecutive even integers algebraically. And we mentioned on the previous slide how to represent 2 consecutive even integers algebraically. So we'll let x represent the smaller of the two consecutive even integers, and we'll let x plus 2 represent the larger of the two numbers. Now, as I read this problem, the next thing that jumps out at me are the words is 52. So something is 52, which means something is equal to 52. So I'm just going to go ahead and write equals 52 because I know I'm going to have an equation that I need to solve that's going to contain an x and an x plus 2. And whatever I do to those x's and those x plus 2's is going to equal 52. Well, what is it that equals 52? It's the sum of the squares of those two numbers, x and x plus 2. Well, if it's the sum of the squares, the sum means I'm going to have to add the two squares of those numbers together. When I square the first number, x, I get x squared. And when I square the second number, x plus 2, we get the sum x plus 2 squared. So there is the sum of the squares of two consecutive even integers that equals 52. Now we need to solve this equation. First, let's simplify the binomial x plus 2 squared. Remember, that is x plus 2 times x plus 2. So that's a FOIL situation. Bring down the first term, x squared, bring down the plus, and when we FOIL x plus 2, we'll have x squared plus 4x plus 4, and that is equal to 52. Now let's combine our like terms, the x squareds, and we'll have 2x squared plus 4x plus 4 equals 52. This is a quadratic equation. Let's solve it by factoring. The first step to solving a quadratic equation by factoring is to get all terms on one side, 0 on the other. So let's subtract 52 from both sides. Subtracting 52 from the right side gives us 0, and subtracting 52 from the left side gives us 2x squared plus 4x minus 48. Now let's factor the left side. There's a GCF of 2, and when we divide 2x squared by 2, we left with x squared. When we divide 4x by 2, we're left with 2x, and dividing negative 48 by 2 leaves us with minus 24. Let's continue factoring x squared plus 2x minus 24 because that's a trinomial with a leading coefficient of 1. Bring down the GCF. That trinomial will factor into two binomials. The first term in each binomial must be x, and then we need two numbers that multiply to give us negative 24, but add to give us 2. Those two numbers are 6 and minus 4. Now that the left side's fully factored, we take each factor that contains a variable, set that factor equal to 0, and solve. That'll give us x plus 6 equals 0, and x minus 4 equals 0, which in turn gives us x is equal to negative 6 and x is equal to positive 4. I've condensed our work down over here on the left side because we're going to need some more room. Because we just found that x can be negative 6 or positive 4. Well, if we found two values for x, then we've only found two values of our smaller of our two consecutive even integers. So that means negative 6 is the smaller of two consecutive even integers, and 4 is the smaller of two consecutive even integers. Now we need to find the larger consecutive even integer that goes with each of those smaller ones. To find the larger, all we do is add 2 to the smaller. So we'll have x plus 2 is equal to, well, in this case, if x is negative 6, we'll have negative 6 plus 2, and that will be equal to negative 4. So for this particular solution of negative 6, the larger is -4. So -6 and -4 are two consecutive integers that will make our equation true. Now that's also true when x is equal to 4. Let's find the larger consecutive integer that goes with x equals 4. Well, if the smaller one is 4, add 2 to that to get the larger. So that means +4 and +6 are also two consecutive even integers that will make our equation true. This example says if 12 is added to 6 times a number, the result is 28 less than the square of the number. And we need to find all numbers that make this work. The first thing that I'll notice is it says that if 12 is added, so that lets me know right off the bat, we're going to be adding 12 to something. So I go ahead and put blank plus 12, because I know we're going to add 12 to something. Let's not worry about that something right now. But then as I go on down in the sentence, past the comma, I see that the result of adding 12 to something is 28 less than something. Anytime I see the words the result is, that means equals. And what is the result? It's 28 less than something else. 28 less means we're going to subtract 28 from something. So there's my something, and I'm going to subtract 28 from it. Now we just need to fill in the blanks. The first blank is going to be filled in by 6 times a number, and the second blank is going to be filled in by the square of the number. Well, both of these phrases reference a number, so we're going to let x be our unknown number. If x is our unknown number, and the first blank is 6 times that unknown number, that means that our first blank will be 6 times x, or just 6x. Our second blank will be filled in by the square of the unknown number. Well, the square of x is x squared. So our second blank will be filled in by x squared. And that gives us our equation, 6x plus 12 equals x squared minus 28. I notice that this is a quadratic equation, so we need to get all of our terms on one side of the equal sign and everything else on the other. I'm going to move the 6x and the 12 from the left side of the equation to the right side of the equation so that I don't have to move my x squared term and change its sign to a negative x squared, because that's what would happen if I move the x squared from the right side to the left side of the equation. Not that it's that big of a deal to have a negative x squared, I just don't want to deal with it. Subtracting 6x from both sides gives us 12 equals x squared minus 6x minus 28. Now let's subtract 12 from both sides. That'll give us 0 on the left and x squared minus 6x minus 40 on the right, because minus 28 and minus 12 combines to give us minus 40. Now we need to factor the right side of this equation. So we'll have 0 equals x squared minus 6x minus 40 is a trinomial with a leading coefficient of 1. Trinomials with leading coefficients of 1 factor into two binomials where the leading term in each binomial is an x. Now we need two numbers that multiply to give us negative 40, but add to give us negative 6. Those two numbers are negative 10 and positive 4. Now we set each factor equal to 0 and solve. So we'll have x minus 10 equals 0 and x plus 4 equals 0. That gives us solutions of x equals 10 and x equals negative 4. So as it turns out, there are two numbers that will fulfill the requirements of this equation. So when we let x be our unknown number, we should have let x be our unknown numbers, because 10 is a solution and negative 4 is a solution.